Welcome to The Explainer. Today, we're embarking on an absolutely epic, deep-time geological story. I mean, if you've ever felt under pressure, well, wait until you hear about the immense, literally unstoppable forces that forged modern-day Turkey. It's wild. Let's dive right in.
So here's a fascinating little mystery for you. If you hike up to the very top of certain high mountains in Anatolia today, you'll find marine seashell fossils just sitting right there at the summit. I mean, how on earth does a deep ocean floor become a towering mountain peak? To figure that out, we have to rewind hundreds of millions of years, because Anatolia wasn't just formed by land quietly rising up. No, it's the chaotic result of continents tearing apart, entire oceans completely vanishing, and massive tectonic plates violently crashing together.
To make sense of all this, we're going to follow a chronological journey. We'll start with the breakup of Pangaea, check out the vanishing Tethys Sea, the massive Eurasian and Arabian Plate collision, the fragmented Anatolide-Tauride block, how the region literally escaped a tectonic vice, and finally, how all of this drives Anatolia's active fault lines today.
All right, Chapter 1, the breakup of Pangaea, a supercontinent torn apart. Just think about the sheer, unimaginable scale of history here. We're talking 300 million years ago. Back then, almost all of Earth's landmass was grouped into one giant supercontinent, Pangaea, and it was surrounded by this massive ocean called the Paleotethys. But deep beneath the surface, intense heat was brewing. It created these incredibly powerful convection currents in the Earth's mantle. And slowly, but absolutely surely, those subterranean currents literally ripped the ancient crust apart, setting all our modern continents into motion.
Which brings us to Section 2, the vanishing Tethys Sea, an ocean squeezed out.
So during the Permian period, we're talking way before the dinosaurs, the area that makes up present-day Turkey was actually just a piece of the northern edge of this giant southern landmass called Gondwanaland. But as everything started breaking apart, a brand new ocean basin, the Neo-Tethys, was born. Picture a massive multi-armed ocean wedging itself behind a newly separated continent. Over tens of millions of years, that older ocean was dragged down into the earth and totally consumed. The birth and death of these seas literally laid the foundation of modern Eurasia.
Geologists actually point out that the mountain ranges of Turkey are a crucial part of the Mediterranean Alpides. You see, the relentless closing of those ancient oceans squeezed the seabed, aggressively scraping and folding the ancient ocean floors upward. And boom, that is exactly how those marine fossils found their way to modern mountain summits. The Turkish Oriyot, basically the zone where these mountains were built, was quite literally forged from the death of the Tethys Sea.
Let's jump to Section 3 and see how this builds into an unstoppable collision.
The Eurasian and Arabian collision, the jaws of the vice.
If you really want to understand the geology of this region, you've got to picture a giant continental vice. Up in the north, you have the massive, totally unyielding Eurasian Plate. Think of it as an immovable brick wall. Then, down in the south, you have the African and Arabian plates, and they are relentlessly pushing northward. Caught directly between these colossal tectonic jaws is the entire Mediterranean and Middle Eastern region. It is, without a doubt, one of the most violent slow-motion crashes in Earth's history.
Now let's look at Section 4. Caught right in the middle of this mess is the Anatolide-Tauride block, the microcontinents.
Because of millions of years of rifting, the landmass trapped between the big plates wasn't just one solid, clean piece. It was more like a shattered windshield. You had all these fractured microcontinents. You've got the Pontettis up north, the Anatolia-Tauride platform right in the center, the Arabian platform down south, and smaller fragments like Bitlis Paturgia. Under the immense, crushing pressure of those closing oceans, these geological fragments collided and were just eventually welded together.
And that brings us to the real climax of our deep time narrative in Section 5, escaping the tectonic vice, the westward squeeze.
All right, by the time we hit the Miocene epoch, Arabia terminally crashes into Eurasia along what geologists call the Bitlis-Zagros Suchu. That's essentially the scar where the plates welded together. Mechanically, here's how it plays out step by step. First, Arabia relentlessly rams into Eurasia. Second, the crust in eastern Anatolia aggressively thickens up just to absorb that impact, but eventually it just can't absorb any more pressure. So in step 3, we get what's called tectonic escape. Think of the Anatolian block like a wet, slippery watermelon seed pinched tightly between your thumb and forefinger. You squeeze hard enough, and what happens? The seed shoots out sideways. That is exactly what happened to Anatolia.
Which brings us to the modern era in Section 6, Anatolia's active fault lines. The Earth still moves.
Now, you've probably heard of the North and East Anatolian fault lines, but it's super important to realize that these aren't just random, accidental cracks in the dirt. These are mandatory, newly generated, transformed fault boundaries that were quite literally created to accommodate that massive tectonic escape we just talked about. The ongoing collision between Arabia and Eurasia basically forces the Anatolian Plate to move, and these major faults are the tracks along which that massive block of crust slides. Current research on Turkey's Tethyan evolution highlights just how intense this process was. The collision eliminated the very last of those oceanic basins and fractured the crust simply to relieve the stress. And here's an interesting detail. While the main Anatolian block was getting squeezed westward, like our watermelon seed, the shear pressure simultaneously pushed other considerable chunks of crust eastwards along those new transform faults. The continental pressure is just so immense that it's actively fracturing and shoving massive pieces of land in multiple directions just to let off steam.
And the craziest part? We know for an absolute fact that this ancient process is still happening right beneath our feet today. How? Modern GPS tracking. A recent study analyzing the 2020 Aegean Sea earthquake used the highly precise TUSAGA active satellite tracking system to measure crustal deformation. The data unequivocally proves that the Anatolian Aegean block is actively escaping counterclockwise toward the Hellenic Arc near Greece. So literally every millimeter tracked by those satellites is a direct, living continuation of Pangaea breaking apart 300 million years ago. How cool is that?
So, as we wrap up this explainer, I want to leave you with a final thought to ponder. We've traced how a deep ocean floor was slowly pushed into towering mountain peaks over hundreds of millions of years, and we know from our modern satellites that the Arabian and African plates are still marching northward, while the Eurasian plate still absolutely refuses to budge. So, as this tectonic vise continues to squeeze, what do you think the map of the Mediterranean will look like a million years from now? The Earth is alive, it's constantly moving, and the map? Well, it's far from finished. Thanks for joining me on this deep dive into our shifting planet.